Hello everybody, this is a functional groups tutorial. This is number 2 in this series, so if you haven't seen functional groups tutorial 1, you should go back and check that out. There's a worksheet for that tutorial and there's also a worksheet for this tutorial, so go ahead to my website at zerobio.com. The link is in the information section below. Print out the downloadable worksheet and then follow along with me. All right, so we are talking about functional groups, and functional groups are the parts of a molecule that give it its special characteristics and determine its reactivity. And in functional groups tutorial 1, I went through many of the typical functional groups that you would see in the grade 12 biology course. I didn't, of course, do them all. I want to introduce a couple of new ones in this tutorial and also go back over some of those old ones. So I've got an image here on the downloadable worksheet of a big molecule that I designed. I'm not saying that this is a real molecule, that it exists, but it does follow the basic rules in terms of carbon having 4 bonds, hydrogen always having 1 bond, oxygen having 2 bonds, and phosphorus here having 1, 2, 3, 4, 5 bonds. Okay, so we're going to go through this, and I think the first thing that I'm going to do is I'm going to introduce the 2 new functional groups that are in here. All right, so go ahead and circle along with me and label these as I do it as well. So down here you can see carbon attached to another carbon. Now there is a ring structure here. I'm going to talk about that in just a moment. But this carbon has 3 hydrogens around it. This is a very common arrangement that you will see. And I'm going to circle this whole thing right here. And this is called a methyl group. All right, so go ahead and label that methyl. Now, there are other methyl groups in this molecule. We're not going to focus on all of them. And it's, like I say, it's very, very common to see. And a lot of courses don't really consider it a functional group. It's not like it does that much. But I just wanted you to be aware of that, the methyl group. Now, the next thing is this ring-like structure here that has alternating single and double bonds. There's 1, 2, 3, 4, 5, 6 carbons in this ring. And this is a phenyl. So I'm going to circle this whole ring structure here. This is a phenyl group, all right? And really, when I designed this, I started with this ring, and then I started drawing atoms, functional groups coming off it. And that would be a typical thing if you were looking at the chemical structure for something like aspirin or Tylenol, acetaminophen. You know, that fen part in the word refers to the phenyl ring, and then there's often functional groups coming off of this. All right, so look for a ring-like structure with alternating single and double bonds with carbon in the ring, and be careful that we're not looking at the monosaccharide structure for, like, say, glucose. It looks very similar with an oxygen in there. All right, so we've got that. Let's go over here to the right-hand side. We've got NH2 attached to carbon. It's not attached to C double bond O. That would change it. So we're just going to circle just this part, and that is an amino group. Let's go above that. We see C double bond O with an OH attached to it. That is our carboxyl. So this is a carboxyl group. And I'd like you to try to imagine that all of these functional groups could be clicked onto that phenyl ring in the middle there. All right, and this is why when we circle the functional groups, we're not including the other carbon that is attached, just this group. So imagine this amino clicked on here, or this carboxyl clicked on to the phenyl ring, or this methyl for that matter. Let's go above here with the phosphorus atom in here. This is a phosphate group. Now, in a molecule like ATP, adenosine triphosphate, these phosphate groups are attached to another molecule here, and there's 3 of them, and these phosphate groups can be cut off, dephosphorylated essentially off of the ATP, and then to phosphorylate another molecule like glucose in the glycolysis pathway. So you will see that stuff later on. Let's come down here. We have a carbon here with a double bonded oxygen. You got to look on both sides of that C double bond O. On one side is a hydrogen, on the other side is a carbon group, the phenyl ring. That makes this an aldehyde. Okay, coming over here, we've got COC and then just another more of a carbon chain. So this right here, that is an ether. And we'll make our way up here. Oh, I see an OH hanging off on its own. It's not an OH attached to a C double bond O. It's just an OH attached to a carbon chain. So that is our hydroxyl group. Moving up here, we look at this, we go, oh, I see another COC, looks like an ether, but that C has a double bonded O, so it's not an ether. Instead, it's C double bond O with a carbon group on one side and an oxygen carbon group on the other. That makes this whole thing an ester. Okay, now, if you were to grab one of those hydrogens as you circle, it's not going to be the end of the world, but these are the functional groups in this molecule. It really would not be a good idea. I want to show you something here. Don't circle this. It would not be a good idea to circle this and use this as the methyl group like we did down here, because this carbon is really part of the ester. All right, so by the same fashion, when you circle a hydroxyl group and say this is a hydroxyl, you're not going to grab all of this and include that carbon, because again, like I showed you over here, I want you to imagine that this group itself could be clicked onto the molecule, say by an enzyme. It's aminated, or let's imagine another term, another reaction you may hear down the road is deamination, where an amino group is cut away, removed. It's not like you're going to take this carbon as well. You don't say this is the amino group, or else as you break it off, you're breaking the whole molecule. You're just cutting off or adding on the functional group. Same thing with the carboxyl group. You don't include that C as part of the carboxyl group. This C is part of this molecule. This is getting pretty messy, is the functional group. All right? So just be aware of that as best you can and enjoy functional groups. Hope that helps.